Hello everybody and welcome to our webinar. My name is Vladimir Podnos. I am Director of Marketing and Support of Terra Analysis, and today we will speak about new release QuickField 5.9. I will briefly explain the new features, and then my colleague from support team, Alex Lubimtsev, will show you some examples. As most of our audience knows, QuickField is a fast and efficient finite element software with extremely simple and straightforward user interface. Set of possible problem formulations is shown on this slide. As you see, it includes electromagnetic, heat transfer, and stress problems. All these types of analysis may be used in combination as coupled MultiPhysics analysis. This slide shows possible ways of interacting between different types of analysis, and the feature which is introduced in 5.9 is shown right on this screen. QuickField requires no training, and new users without any prior experience in finite element simulations may learn its basics in few hours. Package is equipped with virtual classroom, and its lessons and tutorials are sufficient for mastering QuickField without any external help. And of course, when the help is needed, our support team is more than happy to provide it. These are traditional benefits of QuickField, and this is fully applicable to new version 5.9. What is new there? Possibility to take into account the temperature dependence of electrical conductivity in various types of electromagnetic analysis, and import of DC-biased magnetic permeability distribution into AC magnetic problems. Let me explain this in a little bit more detail. Electrical resistivity and the reversal value, electrical conductivity of the majority of materials depends on the temperature. For metals, the conductivity usually falls with the rise of temperature. For dielectrics, it rises with rise of temperature. On this slide, you see examples of material properties for some metals, for carbon and silicon. For this, this slide shows the usual dependency of the electrical motor insulation against temperature. But generally, it is possible to define this dependency as some kind of formula or table. And QuickField 5.9 provides possibility for this. Three types of problem formulations: DC conduction, AC magnetics, and transient electromagnetic analysis allow now temperature dependency of conductivity for each material. Temperature of each block may be also defined as a constant or formula. Moreover, AC magnetic analysis supports import of the temperature from the corresponding heat transfer problem using our regular problem coupling mechanism. This complements the old feature importing of the Joule losses from AC magnetics into the heat transfer, and such combination allows very realistic ways of simulating variety of electromagnetic devices like transformers and motors. Alex will show this in more detail in his part. Another major new feature of QuickField 5.9 is also related to the nonlinear problems and coupling, but this time it is related to magnetic analysis. It is known what media response to the applied magnetic field is depending on the field intensity. This slide shows BH curve for ferromagnetics. As you see, it is not a straight line, it's some curve. In many cases, it is possible to neglect this effect and consider magnetic permeability as a constant, making the problem linear. If the problem is linear, then with time harmonic source currents in complex formulation, it may be considered as a static problem and solved in one iteration without time stepping. This approach is used in QuickField for AC magnetic analysis. But if the source currents are a combination of large DC offset and small oscillating AC component, then DC field affects the magnetic materials and shifts the working point of the BH curve due to saturation. However, for analysis of the oscillating field caused by small oscillating current, may be still considered as a linear problem if the material properties are adjusted to the actual levels due to DC bias. Previous versions of QuickField required the full-scale transient electromagnetic study to be applied for such cases. But now it is possible to solve this problem in 2 steps. First, we should solve the DC magnetic problem, where the DC bias will be taken into account and all materials will be driven into the actual levels of magnetic saturations. And then this distribution of magnetic permeabilities may be imported into the IC problem. This is much more fast and efficient than setting up and then solving full-scale transient nonlinear electromagnetic problem. These are main differences between QuickField 5.9 and previous versions. Platform requirements are pretty much the same. Practically any personal computer under Windows XP, Vista or Windows 7 may run QuickField. Recommended configuration for professional version includes 2 GB of RAM, which is enough for practically any mesh size. But if your multiprocessor system is used for performing the parametric serial analysis using label mover, which may set several sessions of QuickField in parallel, then larger RAM size will be an advantage. Licensing options and pricing are also same as before. Customers under maintenance get QuickField 5.9 for free, and older versions without maintenance may be updated for 50% of the current cost of compatible QuickField configuration. These are our regular terms, and we will be glad to discuss any needs and find the appropriate solution for any particular case. Just contact us or your QuickField reseller. Now, after the short poll, Alex will show you some interesting examples.